Hello everyone. In this video we are going to talk about the function calling in Raspberry Pi ARM assembly instruction set. I have created a small file script in ARM assembly instruction set that will call a function. Okay, and after that you will see that how we can call the functions and how we can return from the function using this few instructions here. So let's see. So what's the main uh, in like originally when we write a function or we call a function from the main, we need to return back to the original section from where the function was called initially. Okay, so for example we have this file here, and this file is basically is just calling a function which is basically multiplying by this, it's multiplying this number 5 by 4 and just simply returning the answer. Alright, so what we do by start, we declare the dot data section, we set the alignment to 4 bytes, and then we declare 3 words. We have num1 word 5, and then since now we have like function calling scheme here, so we need to store the return addresses, because when the function is called, you know, the link address which is used to store in the link register, this is used to be overwritten. Alright, so when this function will be called, the original value of LR, like where the it has to return the to get the return to operating system, that is now overwritten, because when this jump instruction will be executed, it has to return that address. But if we don't store it properly and we don't add some few instructions properly, this won't work then. So we need to take care here for some things so that this will run smoothly. Alright, so we need to save the return addresses for the sections where we are calling the functions. Alright, so for that purpose these are two variables that going to be the storage for the return addresses for those places from where the function was called. Alright, so this is the return address 1 and this is the return address 2. So return address was the original return address that was basically has to be here at particular this instruction, like when the main has to exit and it has to give back the control to operating system. So that original address of the link register that has to be stored. So whenever we have to now write the code in assembly that needs to store that needs to call the function, so we always need to store the return address that was originally in the link register. Alright, so what do we do here? We simply load the return address. Okay, like we have to store it in the memory. Alright, so this memory is basically declared here, and its address space is declared right in the very end of the program. It's just like we have been doing in the previous set of codes and series, if you remember. So again, for the num1 variable we have this address declared here, and for the returning addresses we have these two variables here. Alright, so first we need to load the address of this particular variable, return address 1, and we need to store the original value of link register, which is basically address to give control back to the operating system. We need to store this on this memory address. So this will be stored in this variable once this instruction will be executed. Alright, now what I'm going to do is that since I know I have saved my return address, now I can safely call the function. But for that I need to, let's say I need to read that number that I want to multiply with by 4. So I will load it in R0 register here. Alright, first I will load the address, and then I will dereference it and load the number in the same register R0, which is, you can say, this is my parameter for this function. Alright, and then I'm going to call the function. So this is the instruction to call the function. So this is instruction is BL, and simply we have to mention the section name. So you can see that section name and the function name in this context are both the same thing. So section and function are the same thing. So but when we say BL, means we are treating this section as a function call. Alright, so So what this BL command means and what it does, this means branch and link. Alright, so branch and link means that we need to jump on this section. So it will jump on this section, but what is going to do that, it is going to override the LR register with the address of this next line, which is this one. Alright, so this line address is now going to be saved in LR register. Alright, so you can see this value will be overwritten. So if you won't save it then and won't load it back before exiting, it will just keep jumping over here. Alright, so since we have now stored the variable, so we can call the function. It will now override the LR register and will store the address of this particular line, which is going to be returning, because once this function is completely executed and wants to return to the main, so it has to jump back to this next line so it can continue the code from here. Alright, so let's jump to this section, which is a function which is multiplying by 4 any number which is stored in num1 variable. Alright, and let's see what it's doing here. So whenever you enter a function, again just like we did in the main function, the good practice is that whenever you enter in a function, whether it is main or not, since it is going to be a lot of it's going to have a lot of series of function calls, we need to always store the link register address, alright, in some memory or at some place, so it can be stored back to the so it can be loaded back to the at that time when it has to exit from a function. Alright, so and this because you can see again the same instruction that is exiting the main, the same instruction here, it is basically used here, which is bxlr, and it means branch to the address which is stored in the link register. Alright, so we store this now second address. Alright, return address. Okay, we are simply loading the address of that place that is going to store the address. Alright, and this is going to be stored in that place. Alright, so basically this line's address, which was the return address for this particular line for this function call, so this is stored here at this particular variable, which is return address 2 here. Alright, and then we simply move the value 4 in R2 register and multiply it with R0 and return the answer in R0. So my the parameter just is basically my answer register, so it's going to store 20. And now I have to exit from the function. So what I'm going to do, I'm again going to load the address of that memory that is stored, have stored the link register address, the original address of this particular line. I'm going to load it back, and again since I'm going to return it to that place, it will branch to that link register address. So when this function will be returned or exited, this will jump right exactly at this place. Alright, but specific to in this scenario, if we don't add these instructions, alright, and we simply say bxlr, it will still run fine, because in this particular section or in this function we are not calling any further functions. Alright, so if we are going to call further function calls, if we are going to make further function calls within this same function, then definitely this instruction will be needed, and they will be very handy to keep those in these places, so that at the correct place the address will be returned or the execution point will be returned in the program. Alright, so particularly in this program you can run this without needing these instructions, these two and the last two, but just to be on a safe side and for the good practice, it is a good practice that you always store the address of the previous returning point here, and whenever you enter in a function, and load it back to the link register address, and then jump to the link register address, so that return to the exact point. Alright, so when it will return to now this point, now what it's going to do is that now we need that the address of the previous returning address that has to give back to control to the operating system. So that was stored in this variable. Alright, as we did that here, we dereferenced it and we stored here. Now it's going to load it back again here, okay, and it's going to dereference it, and then it's going to jump back to that place, so the return will be given to operating system, and our program will be properly exit. Alright, so that's how it is written, and these are the address spaces that has to declare just like before we did. So let's save it and compile it. Alright, so let's check out our make file. So make sure you have make file correctly written with these program files names. Alright, you can quit it and then simply run make, so it has executed properly. Alright, now since the multiplication answer was stored in R0 register, so the answer 20 you should be able to see right here on console as well. Alright, so let's say /func and colon echo, then dollar. Okay, so you can see the 20 correct answer is printed here. Alright, now for example, if you want to debug it, alright, and we want to actually see okay how these things are working, so we can see that in GDB as well. So let's open the GDB /func. Okay, now start it and disassemble it. Okay, so now the main has started and it is pointing to the very first instruction of our main section. Alright, you can see the address spaces that are being loaded here, okay, to dereference them and to store them and load them here. Okay, and just in case if you want to see the values of all these variables that we declared here, okay, I can open it a separate tab here as well. So for example, if you want to see the values of all these, alright, and we can also see them like after the number of execution steps as well. Alright, so if we just want to see the value of the value num, so we can simply say p static int and ampersand num1, so that is 5. Okay, and we declared 5, we know that. Alright, and for example, if you want to see the values of return error 1, so it's currently 0, and similarly for the 2 is also 0 because we declared it as 0. Alright, now let's run these 4 instructions and see what is the status of the different memory locations and the registers. Alright, so say step I, so 1 2 3 and 4. Alright, so it should be now pointing to at this particular instruction, so the function call hasn't been made yet, so we can check that. Still in the main function. Okay, but before going that we want to see the status of our registers, so let's say we have info R0 R1 R2. Do we have R2 right here? Not right now, and we have LR, but in case if you want to see it, okay, I just missed the registers here. So you can see we have 5 in R0, which is correctly loaded here. Alright, from this address space. Then we have in R1 we had this address of the address of this returning address, which was originally for the, this is the address like that is going to give back the control to the operating system. We have some chunk value in R2, and this is the value of the link register. Alright, so if you want to check that this correct value has been now placed at the return address 1 location, so we can simply say p static and ampersand return underscore error 1. So you can see that this value is exactly the same because this is the value we stored at this location, right, return address 1. So our link register address for the to give back the control to operating system, it is now correctly saved. Alright, now we are going to call this function bl this mul by 4, and you are going to see that now lr value will be overwritten with this line address, which is the return address. Alright, so let's do that. So step I. So now it has jumped to main. Okay, and now again, before going further, we want to see the value of registers, specifically lr. You can see now this is the now address has been overwritten, so this is the return address of this line. So back to the main function when it will be exit from this function mul by 4. Alright, so currently we are in mul by 4 function, and let's see assemble it. So it is now at the very first instruction of the mul by 4 function. Now again, it is going to do the same practice as we did in the main function, that is going to store the return address, specifically this address is going to be stored at the another memory location, which is return address to like memory variable there. Alright, so let's do that. So we have step I. Okay, so now if you want to check the value of return address 2 variable, so this particular address is now this variable is saved at return address 2 variable. Alright, so let's check that. P static and ampersand and return underscore address 2. So you can see that this value 66532. This is the decimal representation of this value address, which is 103E4. Okay, so that is the returning address of this particular line. Alright, so it is now saved. Okay, now in the next instruction, what are we going to do? Next two instructions, we are going to move the value 4 in R2 and multiply it with whatever the number we have loaded in R0 previously, which is value 5. Alright, so let's do that. Step I. Alright, and in case you want to see where we are currently standing now, so we are now at this particular instruction. So the multiplication has been done, and our R0 register has now our answer value 20. If you want to check it using the info registers, so you can see it from here now, that is that now R0 have the value 20, which is our answer. Okay, and the R1 and R2 has value 4. R1 has the registers the address value of the previous return address, and this is the other return address for the main. Alright, and let's execute the last two instructions. Alright, to see and probably after execution of these instructions, the value of LR will still be unchanged. Alright, so let's do that. Okay, and if you want to check the values now, you see the value of LR here is still unchanged, because within this function we didn't make any further function calls. Alright, and in case just I explained before that if you remove these 2 to 4 instructions, 2 from above and 2 from this below side, if you remove those instructions, the value of LR will still be will not be affected, because we haven't called any function further here in this particular function. So if we made a further like BL any section function call, then the LR value will be overwritten, and for that purpose these 2 to 4 instructions are very handy. That is going to store and then load the correct link register, the returning address here, and so that the rest of the executions can be done. Alright, so currently now it is pointing to at this place if you want to check it. Alright, so this is so now it will be jump back to the address, which is 103E4, that was return address in the main function of the next line, from where the function call was made. Alright, so if I say step I, okay, now it is back to main at this address, and if you want to see it, that code where we are standing. So you can see now this is the returning address which was saved, like correctly it was used. Okay, and now we are properly returned back to our the next line from this function call, and now the rest of the code is going to execute. So in the next two lines, what is happening, that it is again going to load the address of the return address variable one, which is the return address of the to give the control back to operating system. All right, so this is where it is going to dereference and load back that register in LR, and then finally BXLR, when it will be executed, the main program will be exited. All right, so if you see, just execute the two instructions here. Okay, and now we see the values of our registers, specifically the LR register. So the value is now changed. So this is the address value of that place, that is the operating system. All right, so now we are standing at the very last instruction to execute, to exit the this function and program. So if you just run from here, the continue, so it will execute all the series of instruction. Okay, after that, so that's how our program is exited, and our answer was correctly was stored in register R0 that had output here in that console area. All right, so if we quit it, so it will successfully quit. All right, and if you want to again to see this answer output as here, we can execute this file again. So /func colon echo, and we have, so that's here the 20. All right, so that was all for this video for the time being, that how we can call the function in ARM instruction set and execute that on Raspberry Pi 3 or any Raspberry Pi architecture or any ARM architecture system. And in the next video we will see that how we can operate with the parameters for the function. So currently you can say it was a kind of like parametric function that we did with just one parameter. But for example, if you want to save some parameters and want to make the function transparent, just like we used to do in the high level languages, like sometimes the value has to be passed by value or it has to pass by reference. So how are we going to maintain that? All right, we will see that in next video hopefully. So take care for now, and thanks for watching the video. Please subscribe the channel. All right, thank you, bye.